Okay. So this is the definition of locus of a point. It is a path or a curve traced by a moving point which satisfies some given conditions. So the simplest of example is this. P is a point which is moving on a circle. So the condition that P will have is the distance of P from the center will be constant, and that will be equal to the radius. So we say P moves such that its distance from this point C is constant, and the locus of P is a circle. So that's the definition of locus. And equation to the locus. We may physically understand, okay, this is, it will be a circle. Each time it is difficult to understand what the figure is for different conditions. So we have to go by equations. Equation to the locus. So what does equation mean? It is the algebraic relation. It is the algebraic relation of the locus of the point which satisfies given conditions. So this is the equation to the locus. This is what we will be doing, how to find equation to the locus in this particular class. So how to find? Steps to find the equation to the locus of a point. Steps to find the equation to the locus of a point. So first step to do is assume the coordinates of the point P to be h comma k. This is the easiest way to do. Then P is the point for which locus has to be found. Locus of a point P. Now write the conditions involving P h comma k. Whatever the conditions are given, we'll do examples, you'll see. So first step is to assume the point to be h comma k, write the conditions. Now eliminate any variables any unnecessary variables, if any. So you will get one relation. Then finally replace h by x and k by y. Okay. This relation in terms of x and y is the equation to the locus. Take down. Once you have taken down, just let me know. Now we'll do problems on these. So again, I'll repeat the steps. First step is write P as h comma k. Next, write conditions involving h comma k. Next, eliminate any variables. We'll see how to eliminate when. And then replace the h by x and k by y. Then this will give you equation to the locus. All right. Now, very important, this locus problems throughout the coordinate geometry, not just in, now it is not just a small topic, it will be throughout the coordinate geometry one of the most important problems, and in fact one of the very challenging problems also. When you go to straight lines, circles, parabola, ellipse, hyperbola, conic sections, you learn all these things. In that, locus problems will be involved. So let's go further. Now, problems on locus. Problems on locus. The very first problem. Find the equation to the locus of a point which is equidistant from -1 comma -1 and 4 comma 2. Okay, find the locus of a point which is equidistant from -1 comma -1 and 4 comma 2. So I'll take down this problem. I'll explain the steps because it's a first time. So let the locus, let the point for which locus has to be found be P h comma k. All right. Now, given points are A -1 comma -1 and B 4 comma 2. All right. Now, given condition is that PA, distance of point P from A, is equal to the distance from point P to B. PA is equal to BP. Locus of a point which is equidistant from 2 points. So we apply P and A distance is equal to P and B distance. So what will this give? Now we know that the distance formula is under root, right? Now to eliminate the under root, we can square both sides. PA square will be equal to PB square. So now when you square it, the distance formula P is h comma k, A is -1 comma -1. So distance formula is h of -1 whole square, x1 minus x2 whole square plus y1 minus y2 whole square under root is equal to pb h minus 4 the whole square plus k minus 2 the whole square. So what do you get? This is h plus 1 the whole square. With practice, you will write directly. In the beginning stages, I'm just writing each step very carefully for you. And remember, in your boards, you should write all steps very, very clearly. But when you come to competitive exams, you should be able to skip steps and jump ahead. All right. So now you see this. Expand this. A plus b raised to second power. So a plus b whole square. So it is h square plus 2h plus 1 plus k square plus 2k plus 1 is equal to h square minus 4h plus 16 k square minus 4k plus 4. What happens? You have both sides h square cancel, h square cancels, k square cancel, k square cancel. Okay. Now
Plus
this
6h plus 6k.
yes. Now let us see. This implies this 2h, bring this 4h this side, it becomes 6h. Then 2k minus 4k. Okay. Did I? I'm sorry. I'm sorry. I made one mistake. Where did I make mistake? Anybody? This is right here. This is 8h. H a square minus b, a minus b whole square is a square minus 2ab. 2 times 4, that is 8. All right. So you get 2h minus minus 8h. You bring this side, it becomes 10h. And this is 2k minus 4k, it becomes 6k. Now this is 1 plus 1, 2 this side, 16 plus 4, 20 on the other side, which comes this side, it becomes 2 minus 20, that is minus 18. Now you can divide by 2.
2.
5h plus 6k minus 9 equal to 0. Therefore, locus, replace h by x, k by y. Therefore, the locus of P is
5x plus
5x
3y.
minus 9 equal to 0. Good. 5x minus plus 3y minus 9 equal to 0. Please take down. And what is this? I'll just explain. By the time you take down, have you taken down?
Yes, sir.
Generally, I don't need to show a grapher. I can show just here what this locus means. Right now it is just some equation, but when we study straight lines, you will understand what this locus means. All right. Generally, you have 2 points. You consider the perpendicular bisector of sides. Consider the perpendicular bisector of sides. Now, any point P on the perpendicular bisector will always be equidistant from two given points by similar triangles. You see this. This is a perpendicular bisector. So let's say the foot of this perpendicular is M. Then AM will be equal to MB. And given that PA is equal to PB distance. So, and this angle is 90 degrees. They are congruent triangles. So, on any point on the perpendicular bisector of a line joining AB will be equidistant from A and B. So, this is an equation of a straight line. We will see when we study straight lines. This is an equation of a straight line. It is the perpendicular bisector of the line joining A and B. Okay, although this seems to be a trivial equation now, meaning some equation, but we'll understand this when we do straight lines. But this is how we find the locus. Next, question 2. So let A be the point A comma 0 and B be the point minus A comma 0. Find the equation to the locus of P, a point P, such that PA square plus PB square is equal to 2C square.
So what is C square?
C is some constant. C is a constant, some constant. Will you do? What is the first step? You do it with me. Again, another problem I'll ask you to do by your own. First step is, what is the first step?
So you write it as K and H.
Yes, write P as H comma K. Right? Now, what is the given condition? Just write the given condition. PA square plus PB square is equal to 2C square. So what do we get? A is this. So P is this. P is H comma K. A is A comma 0. What's the distance square? PA square is the distance between PA
So its
whole square.
distance will be A
Right.
because it's on the x-axis.
No. But this is not on P is any point. P need not be on the x-axis. Okay. See,
So what isn't it A? Okay.
got it.
Yes. Sir.
See, say this. Say A is this point, A comma 0. And this is minus A, minus A comma 0. Now, P can be any point satisfying this condition. All right, it need not be a point on the x-axis. So now, PA square is H minus A the whole square plus K minus 0 the whole square plus PB square. H P is H comma K, B is minus A comma 0. H minus of minus A, that is H plus A the whole square plus K square is equal to 2C square. So expand h square minus 2 ha plus a square plus k square plus h square plus 2ha plus k square is equal to 2c square. This 2ha minus and plus 2ha, they cancel because plus and minus becomes 0. Then h square plus h square is 2h square. K square plus k square is 2k square. I'm sorry, this is not, I missed an a square here. H square plus 2ha, I missed an a square here, plus a square. So then a square plus a square is 2a square is equal to 2c square. 2 cancels, throughout 2 cancels, you have h square plus k square is equal to c square minus a square. Therefore, the locus of P is x square plus y square is equal to c square minus a square. Got it? This is actually a circle. Okay. Later we'll see if you change you give c different values, you will get different results. Done? Taken down? Done? Everybody?
Yes, sir.
Okay. Next is a very simple one which you all can do. Next problem. Very simple one. I want you to do now. The third question. Find the equation to the locus of a point whose distance from the origin is 4 times its y coordinate. Find the equation to the locus of a point whose distance from the origin is 4 times its y coordinate. Please solve. Very, very simple. Give me the answer. Anybody got the answer? Very simple. You should get this answer.
So x square plus y square is equal to 4y.
Mhm. You get x square minus 15y square equal to 0. This is what you should get as the answer. Let's see. So let P be equal to h comma k. What is given? Given condition we have to write correctly. Given condition is that the distance, whose distance from the origin, the distance from the origin means OP is equal to 4 times its y coordinate. Y coordinate of point P is k. It is 4 times k. All right. So what do you get? Under root of, what is the distance of a point from the origin? H minus 0 whole square plus k minus 0 whole square. So h square plus k square under root. You square on both sides. H square plus k square is equal to 16k square. So we get h square minus 15k square equal to 0. Therefore, the locus of P is replace h by x and k by y. So h square minus 15y square equal to 0. This is the locus of P. Later you will learn this represents pair of two straight lines. It's a pair of lines. In the next chapter you will understand this. Taken down, everybody?
Yes, sir.
So next problem. Next is an interesting problem. Yeah, the ends of the hypotenuse. The ends of the hypotenuse of a right angle triangle are 0, 6 and 6, 0. Okay, find the equation. Oh, find the equation to the locus of the third vertex.
So this will be a constant, right? There can be only one point where the third vertex can lie.
No, it can be many points. You will see. That's why it is
So,
asking locus. It is
but then it won't be a right angle triangle anymore.
why there can be many right angle triangles. If you know, good thinking. On the diameter subtends in a circle. The diameter subtends what angle on the circumference of the circle?
So
And
90 degrees.
yes. So how many points are there? There are so many points at which it subtends 90 degrees.
Oh, okay. Yes, sir.
Got it?
Yes, sir.
Good.
But sir, in a diameter, the one point is fixed and one point is not fixed, and
No,
so
no.
we.
Diameter is fixed. I'll show you in that grapher. I will show you. But for right now, you just consider this. All right. See, I'll show you the equation also. What we get. I'll show the entire thing. So this is 6 comma 0. Let's say this is point A, and 0 comma 6. This is point B, and let P x comma y be any point here. P h comma k, in fact. Now this is the third vertex of the triangle formed by PAB, and AB is the hypotenuse. If this is the hypotenuse, the opposite angle has to be 90 degrees. So we have to use the Pythagorean theorem, all right, or the Pythagoras theorem. Mm, no, locus is not an equation of a line. I'll just share right now. So solution: let the third vertex be P h comma k. All right. Then now, given that P AB subtend angle 90 degrees at P, so let A be equal to 6 comma 0, B be equal to 0 comma 6. So given condition, although condition is not directly specified, but through the words, okay, so condition, it is not said that PA square plus PB square is equal to AB square. That is not given. But because it's a right angle triangle, we deduce the condition. What is the condition? Given that PA square plus PB square is equal to AB square. This is the Pythagorean theorem, or the Pythagoras theorem, as we call. All right. So now let us do that. PA square. This is h minus 6 the whole square plus k minus 0 the whole square pb square h minus 0 the whole square plus k minus 6 the whole square is equal to, what is ab square? 6 minus 0 the whole square plus 0 minus 6 the whole square. All right. So now when we expand this, you get h square minus 12h plus 6 square 36 plus k square plus h square plus k square minus 12k plus 36 is equal to 36 plus 36. So this 36 plus 36 gets cancelled here, 36 plus 36. All right. Next, h square, there are two h squares. So you get two h squares. And there are two k squares. So you get two k squares. And you have minus 12h minus 12k equal to 0. So divide by 2 throughout. H square plus k square minus 6h minus 6k equal to 0. Now what is this? So therefore the locus of the point P is,
A circle.
yes, x square plus y square minus 6h minus 6x minus 6y equal to 0. This is a circle. And naturally, so there's a, right now, as you're learning coordinate geometry, you may not understand all the equations. Conic sections will also come in another few problems we'll do. But these are very simple. Huh? These are just based on coordinate systems, the problems that we are doing. Now I'll show you using grapher how this is so. So let us choose these 2 points. What is that? 6 comma 0 and then 0 comma 6. Now center radius form, it's asking circle through 3 points. Okay, I'll do circle through 3 points. I'll explain that. Circle through 3 points. So now see this circle, right? Look at the equation. X square minus 6x plus 9 plus y square minus 6x 6y plus 9 equal to 18. So 9 plus 9, 18 cancels. You get again x square plus y square minus 6x minus 6y equal to 0. Same as what we got. This is a line. This is the diameter. All right. Now any point on this circle, any point, this point is a moving point, let's say, always this angle will be 90 degrees. This angle, I'm not able to mark it here, but this particular angle always will be 90 degrees. So this will be a moving point, and no matter where it is on the circle, always A and B will subtend 90 degrees. So this equation is a circle equation. What we found here is the equation of a circle. Understand?
Yes, sir.
So we just did a few problems. I'll give more. I'll give as a homework because time is up now. Um, I will, for those of you who have registered, yesterday I showed, Google, but we thought about it, me and my friends who are helping me at the background, that Moodle is a very excellent platform. I'll just show you that platform. You have to type in the search AOC. AOC stands for Akshay Online Classes .moodlecloud.com. All right. When you go there, you will get a login like this, and here a sample name, and password. Once you enter, you will get topics like this. All right. So we will load for you, you know, the videos. You can see the, not all classes, but some critical concept classes videos you can see there. You can also uh, you can navigate, and then we'll give you assignments also. I'll load here, and study material also I'll load. Whatever I am writing here, I'll load here. So this will be a platform. This will be totally accessible by you only. You need a password. You need a password to enter into this. Okay. So by tomorrow, I'll give you, for whoever's registered. So then you can start accessing on Locus and coordinate systems. I'll give you an assignment. We again will meet on this topic again on Monday. So you will have some time, not many questions. I will identify a few questions. You solve them and come back. Next class, we'll discuss more problems on Locus. That will be on Monday. Tomorrow's class, tomorrow's class will be on sets and relations, continued relations, and then functions we'll move to. All right, any questions?
No, sir.
Okay, all right, thank you.
Yes, sir. Thank you.
Thank you.
Thank you, sir.
Thank you.